Hi everyone, it's Mrs. Summer here to talk about lesson 803, calculating the pH of strong acids and bases. In this lesson, you will be able to describe the difference between strong and weak acids and strong and weak bases, calculate the pH and pOH of strong acids and strong bases using the following equations. 14 is equal to pH plus pOH. The pH is equal to the negative log of the hydronium concentration. The pOH is equal to the negative log of the hydroxide concentration, and then the concentration of hydronium ions is equal to the 10 to the negative pH. If you recall the pH scale, the more acidic items are between 0 and 6 on the pH scale, neutral is 7, and bases are between 8 and 14 on the pH scale. The pH scale increases by a factor of 10. Each whole pH value below 7 is 10 times more acidic than the next value up the scale. In other words, there will be 10 times more of the amount of hydrogen ions in the pH of 4 than there will be in a pH of 5. So here are some examples of the pH of common household items. Alkaline or basic pHs are drain cleaner, which is a pH of 14, bleach is a base, which is pH of 13, ammonia 12, etc. On the acidic side, we have water is 7, urine, you'd be happy to know, is a pH of 6 on average. Coffee has got a pH of 5, tomato juice 4, soda 3, lemon juice, stomach acid, and battery acid all have increasingly lower pHs because they are more acidic. To represent concentration, we use brackets. So the pH is the measurement of the concentration of H3O plus ions. So H3O plus is hydrogen ions means the same thing, and hydrogen ions mean the same thing. It's just that you won't find hydrogen ions actually in solution. They always react to form an H3O plus ion, which is called the hydronium ion. H3O is read as, the concentration of hydronium ions. pOH is the measurement of OH ions in solution. So this brackets OH minus is read as the concentration of hydroxide ions. So strong versus weak acids and bases. Strong acids and bases, they fully dissociate. What that means is they fully break up when they are dissolved in water into all of either hydrogen ions or chlorine ions. If you look here, it's all Cl minus, H plus, Cl minus. Weak acids or weak bases are something that partially dissociate. So here you have HF, which is hydrofluoric acid, which is a really dangerous acid. However, it's not considered a strong acid by chemical standards because when it is dissolved in water, it doesn't completely dissociate. You would still find some HF ions or HF molecules in solution in addition to the H plus and the F minus ions. Equations to calculate pH of a strong acid and bases. So since strong acids and bases fully dissociate, we can use the following equations to calculate pH and also pH. So the pH 14, because our pH scale is a 0 to 14 scale, is equal to the pH plus the pOH. pH is equal to the negative log of your hydrogen ion concentration or your hydronium ion concentration. Your pOH is equal to the negative log of the OH concentration. And your hydrogen ion concentration, so if you're given the pH of a substance, you can find out the concentration of the hydronium ions by doing 10 to the negative pH and getting that as your answer. So weak acids and weak bases use different equations since they are in equilibrium. So it'll balance out, and so we're not going to cover this in the equilibrium reactions and calculations using weak acids and weak bases until AP Chem. So how do you put log into your calculator? So your log button is right here, kind of next to your 7. So you would hit the negative button. Remember, negative different than subtraction. You want the negative and then log. And then if you're putting in the hydrogen concentration, 5.5 times E, so you're going to hit that second E button to get the times 10 to the negative, and then times -3, you're going to enter that in there as well. Then you'll hit enter. So don't forget to look for E in your answer as you're doing these questions, especially when you're working backwards from given the pH, find the hydronium ion concentration. Okay, so let's do a practice question. Assume what is given is a strong acid or base. A solution of hydrochloric acid has a 0.023 concentration of hydronium ions. What is the pH and the pOH of this solution? So we are given a concentration and we need to find the pH and the pOH. So we're given the acid, hydronium ion concentration. So to find the pH, we need to do the negative log of the hydronium ion concentration. And then to find the pOH, we do 14 minus the pH. So when we plug those numbers into the calculator, we get the negative log of 0.023, which is equal to our pH. And when you compute that in the calculator, you get 1.64. pH is a unitless number, so you do not need to apply a unit to your pH or pOH answers. Then, once we got the pH of 1.64, the pOH is going to be 14 minus the pH, which pOH is equal to 12.36. You try. Assume what is given is a strong acid or base. Find the pH and pOH of the following solution: a 5.2 molar solution of HNO3. So what we first have to realize is that because this is a strong acid, we are a 5.2 molar solution. Since it completely dissociates, that 5.2 molar is the concentration of your hydronium ion. So the concentration of H3O plus is equal to 5.2 molar. Then we're going to do the negative log to get the pH, and I get negative log of 5.2, and I get the answer of my pH to be negative 0.716. Now here's what you're thinking: oh my god, I have a negative, I did something wrong. You can have a negative pHs. Although the scale is 0 to 14, when you have something that is extremely concentrated, especially extremely concentrated strong acid where it all dissociates, your hydronium ion concentration is very high, which means the higher your hydrogen ion concentration, the lower your pH, and it is possible to have a negative pH in this answer. So then my pOH is equal to 14 minus negative 0.716. So my pOH is 14.716. So another question: a solution of sodium hydroxide has a concentration of 8.7 hydroxide ions. What is the pH and the pOH of the solution? So in this case, we are given the hydroxide ion concentration. So we need to calculate the pOH, which is equal to the negative log of the hydroxide concentration. So my pOH is equal to negative log of 8.7. And so my pOH is equal to negative 0.94. And so my pH is going to be equal to 14 minus negative 0.94. And so my pH is equal to 14.94. And this makes sense because the hydrogen or hydroxide ion concentration is extremely high. It's extremely large in this case, which means that because the hydroxide ion concentration is extremely large, it means that the pH is going to be very high because it's an extremely basic solution.